We're going to learn about electron configurations in this video. So you see a tiny example here of how they start. I'll explain how to start them. At first it might seem a little tricky, but they do get a little bit repetitive, so it gets pretty easy once you get it down. So to start with, hold on, let me get my pen out. To start with, you got to look up this element on the periodic table. Sodium's number 11, so that means it has 11 protons. That also means it has 11 electrons. Sorry about that. Because there's no charge here, so we'll assume that it's neutral. So if it has 11 electrons, I'm going to show you how to example on this, and then I'll show you how to use your off-bow chart. I'm going to put 11 electrons in here, following the rules. Off-bow's rule, start from the bottom. Then Hund's rule, single them up before you double them up. That should be 2, 4, 6, 8, 10, and then the 11th electron would go here. So here's how I write an electron configuration of sodium. This is all the electrons in the ground state. They're in the lowest energy they can be. And all I do is I write, okay, what energy level is it in? It's in the first energy level. It's in the sublevel S. And there are 2 electrons in this sublevel. So I put a 2 up here. So it goes energy level, sublevel, number of electrons in that sublevel. So in the next sublevel, so you go from lowest to highest energy, 2s, and there's 2 in that sublevel. The next one, 2p, except there's 2, 4, 6 electrons in this sublevel. And then the last one is a 3s sublevel, and it only holds 1 electron. So this would be the electron configuration of sodium. So our answer would be 1s2, 2s2, 2p6, 3s1. Now I'm going to show you how to do it on this chart as well. What I would do for this one is you always start at the top up here. You go, okay, our first sublevel is the 1s sublevel. It holds 2 electrons. So I'd go 1s2. Then after I get to the end of this arrow, I go to the top of the next one. Next sublevel is the 2s. That's also going to hold 2. At this point I've added 4 electrons. I have 11 total, so I'm definitely going to hit this. After I get done with this, I go up to here. I go through a 2p sublevel. Now a p sublevel can hold 6. Now if I fill this up completely, I'll have 10 electrons. Or I need at least 10 electrons to fill this up completely, because it goes 2, 4, and then another 6 would be 10. But I have 11, so I have more than enough. So I just put the max number, 6, in there. Now the last sublevel is a 3s sublevel. Now it takes 12 electrons to fully fill up the 3s. 2, 4, plus another 6 is 10, plus another 2 for this one would be 12, but I don't have 12. So even though this can only hold up to 2, I only have 1 to put in there, so that's how I end. So for the most part, you just blindly follow these arrows, and then here's how I'd look at it. I'd say, okay, I get to the 2p, took 10 electrons, I have 1 more, that last one will dump into the 3s. So that's where the last 1 comes from. Let's try with another one. Manganese is number 25, so 25 protons, 25 electrons, because it's neutral. So for manganese, I'd follow this, 1s, 2. The next one is 2s, 2, and I'm basically just maxing them out until I get up to, let's see here, I'm going to max this one out, and I'm not going to max this one out. So I'm going to end on 3d. So let's just go fast until we get to there. 2s2, 2p is next, max it out, it holds 6. 3s, max it out. Then after that we got 3p. 3p takes 18 to get to there. We have more than enough. So I put the 3p6. 4s2. After 4s2, I jump out to here. Now I'm at 3d. Now here's the trick. Remember, there are 25 total electrons. 25 total electrons. At this point, up till here, I've used 20. That means I have 5 left. Now, a D sublevel can hold up to 10, but I only have 5 left. So I have to put the remaining 5 there. So even though this can hold 10, I only have 5 to put in it. Let's do the last one. Osmium. Oh, I need to look that one up on the periodic table. Number 76. So this has 76 electrons. So we're going to go back to this chart. So I've got 76 electrons. Let's just remember that number. We go through 1s2. Next one's 2s2. 2p6. Where are we at here? Okay, we're at 2p6. 3s2. 3s2 after the 3s2. 3p6. After 3p6, we go to the 4s2. After that, we jump out to the 3d. So after 4s, we go out to here, 3d. That holds 10. Remember, a d sublevel holds 10. So we've used 30 electrons. If you were to add up all of these numbers on top, it would add up to 30. We've placed 30 electrons. We have 46 to go. So after 3d is 4p. That can hold up to 6. P sublevels hold 6. 5s2. After 5s2, we jump way out to the 4d. 4d in a d sublevel can hold 10. 5p. 6. 6s2, we're getting closer here. After the 6s, we've had 56 now. So we've got 20 to go. So after the 6s2, we jump way out to the 4f. So we've got 4f. Now, remember, a 4 or an F sublevel holds 14 electrons. In order to be able to put all 14 in, we need to have a total of 70, which is fine because we have 76. So I'll put the full 14 in here. Now, again, if I had added up all the numbers along top, the superscripts, I'd have a total of 70 electrons. That means I have 6 to go. 70 minus 6. That means I have 6 remaining electrons. Those remaining electrons are going to get dumped into the 5d. So I go 5d, 6. Now double check, can a d sublevel hold 6? Yeah, it can hold 10, so it'll be fine holding 6. So it's pretty straightforward. You just follow the same exact pattern. They all look pretty much the same. The only thing you got to do is at the end, you got to figure out how many remaining electrons get dumped into that last sublevel. So do a couple practice, pick an element or two on your own, try it, see how it goes, and we'll do some practice in class.